Hey, what's up guys, welcome to my YouTube channel and to my third video. In this video I want to talk to you about the standard model of particle. So watch out and take care. Since from the birth of humanity, we humans has been asking some of the questions like, what is the ultimate composition of the universe? Where did we come from? Why are we here? Why the laws of physics functions the way it is? Well, it seems very reasonable questions that we need to answer and thought to be able to answer, but till now we haven't been able to unlock the secret of the universe. It has been taken a whole era of scientific revolution, but these questions are left unanswered. The question, what is the ultimate composition of the universe, led to discovery of known subatomic particles and many unknown stuffs. The closest but not the ultimate composition of universe has been achieved, what we now call the standard model of particles. Ancient Greeks, later supported by Aristotle, believed that all the matters in the universe are all made up of combinations of four elements: earth, air, water and fire. It has been used as the basis of all branches of knowledge such as medicine, philosophy, astronomy, etc. Perhaps there are four states that matter exists: solid, earth, liquid, that is water, the gases, air and the plasma, fire. It is one of the first answers that attempted to answer the question, what is the ultimate composition of universe? Later, it has been realized that all four elements are matter which is composed of atoms, and it is thought to be the ultimate building blocks of universe. When atoms combined formed a molecule, compound and element. John Dalton in his atomic theory described the building block as atoms and some analysis of the interactions. Later, eminent chemists like Dmitri Mendeleev and Henry Moseley classified the elements what we now call the periodic table, which is now one of the finest classifications ever made. Since then, the realization was not the end of the story. Chemists like Rutherford gave more hints that atoms are composed of further small particles like nucleus and electrons. J.J. Thomson discovered electron in 1897, proton by Goldstein in 1886 and neutron by Chadwick in 1932. Since then, the discovery of three particles of matter was sufficient to describe almost the interactions that we observe in the physical world around. It was cool milestones that did so many cool actions to answer the question. The simplified model of atom is visualized as electrons revolving around the nucleus composed of protons and neutrons like our solar system. Though it is more complex than we have that simple picture. When further zoomed through the three subatomic particles, current advanced technology of science allowed to see more in detail. The story continued when protons and neutrons are composed of small particles now called quarks, and this is where standard model comes in picture. It is the collection of elementary particles that we know so far. It is modern periodic table of particles. The standard model is not as simple as some letters written on and tables are stacked up. Perhaps it is one of the masterpieces developed from discoveries of the various subatomic particles that involved various scientific efforts and budgets. It is a collection of extreme limit of composition of universe that we know so far and the three fundamental forces. Sadly, gravity is not in this picture. While I'll let you know in a minute. So watch out. Explaining such an exciting illustration and breakthrough, I might surprise you with some strange names that ends with suffix -on. Well, I was too surprised and confused at the beginning, but trust me, I'll make it as simple. The standard model has 3 stacks of particles plunged in the Higgs field. I'll get you about Higgs field later. The first and second fall under one category called the fermions, and the other is called the bosons. The fermions are the elementary particle that makes up the visible matter, and bosons are the force carriers. Well, another way to distinguish is with regards to the spin of the particle. The fermions have the integer half spin. It can be 1/2, 3/2, 5/2, etc. and other non-integer spins like 1/3, 4/5 are not observed. We don't know whether they exist or we failed to detect. Of course, scientists failed to detect, let me correct. And only plus half are observed, not like 3/2 and 5/2. And the other side, bosons have the integer spin of 0, 1, 2, 3, etc. The fermions are further classified into 2 types, quarks and leptons. There are 6 quarks known so far: up, down, charm, strange, top and bottom. Up and down are found in nucleus of an atom, and others require advanced particle accelerators to detect them. Leptons don't interact with strong nuclear force. There are 6 leptons, 3 being charged and 3 being neutral. They are electron, muon, and tau. The neutral leptons are neutrinos, which comes from the above sources, namely electron neutrino, muon neutrino, and tau neutrino. All this makes up the 12 elements of the ordinary matter. To understand bosons, we need to have some basics to understand. There are 4 known forces of universe, namely gravity, electromagnetic force, strong and weak nuclear forces. In the subatomic realm, the strong nuclear force is the strongest force, where the gravity is the weakest force, which makes gravity insignificant for the consideration in the standard model. The gravity is the force at the largest scale, which governs the motions of the heavens, makes apples to fall, makes balls slow down, and makes the planets revolve around the sun. The electromagnetic force makes the intuition of sight, that is light, lasers, and photoelectricity, magnets that attract things. The strong forces binds neutrons and protons in the nucleus, which explains why stars shine, why nucleus exists. The weak nuclear forces helps us to explain how the nuclei of the unstable heavy elements undergo radioactive decay. When talked about the force, in plain language, it is rather regarded as pull or push. When the force is applied, there is exchange of some particles that we don't see but gets exchanged, resulting in it. So these are the 3 elementary force carriers. Photons, which is neutral for electromagnetic force with a spin of 1. Gluons, which is neutral for the strong nuclear force. W and Z boson, where W is in plus or minus, and Z boson. The standard model predicted that all 3 elementary particles must be massless. Of course, it is not true. Even neutrinos that we thought to be massless has non-zero mass, and bosons like photons has no rest mass. To address this problem, to explain where some particles get mass from and some not, Higgs theory was developed. Peter Higgs, along with scientists, predicted the existence of another field called the Higgs field. When excited Gibbs particles, Higgs bosons. It is when some particles like quarks interacts with the Higgs field get its mass, and some don't interact, such as photons has no mass. The particles which interacts more are heavier and less lighter. Higgs boson was discovered in 2012 at Large Hadron Collider (CERN), which earned Nobel Prize for Peter Higgs and Englert in 2013. Even though the standard model gave us a refined picture and the composition of the universe, it only constitutes roughly 5% of the total matters in the universe. And even it is not ultimate building blocks that we think of. So there comes the picture of superstring theory, which I will take video on that. Others are thought to be dark matter and dark energy, which constitutes 95% of the universe. But all particles discovered constitutes 5% of the universe, and rest particles or energy carriers has not been known so far that account for dark matter. It means that we don't know still 95% which universe is made up of. And moreover, mysteries has been still not solved, like why universe has to be made up of quarks and leptons, why there should be 4 forces or even more undiscovered. For almost scientific era, the questions beginning from how have been somewhat answered, but why turn out to be still difficult questions to answer. Maybe physics enthusiasts will tell us someday. Let's wait for it.